Hello friends, today I will solve a LeetCode medium problem. So the problem is we are given a positive integer days representing the total number of days an employee is available for work, and we are also given a 2D array meetings of size n where meetings I represent start I to end I, which represents the starting and ending days of meeting I. So we need to return the count of days when employee is available for work but no meetings are scheduled. So we need to count the number of days in which no meeting is scheduled for an employee. So I'll discuss the solution with an example. So let's consider the first example. So I'll start with the brute force approach. So I have taken the first example which sets the number of days at 10 and there are 3 meetings. So I have declared a boolean array of size day plus 1. So what we will do, we will take each meeting. So let's say one meeting is from I to J. So for each meeting, we will start a loop from index I to index J and we will mark all those indexes as true. For example, let's take from index 5 to 7. So we'll run a loop from index 5 to index 7 and we'll mark all the indexes as true. This is true, this is true, this is true. Similarly, for index 1, comma 3, I'll start a loop from index 1 and I will mark all the indexes as true till index 3. Similarly, for index 9, comma 10. So I will mark all those indices as true. So then again I will run a for loop from index 1 to days. Then I'll find out the indexes which are, so initially all the indexes will be false. So I will find out the indexes which are false and I will maintain a count variable result. So when I'll be at index 4, I'll increment the result variable to 1 and at index 8, I'll increment by 1. So the result will be 2. So at the end, I'll basically calculate all the indexes which are marked as false. So initially all the indexes will be false and I will be marking them true whenever I will traverse each meeting. So to calculate time complexity, so each meeting can have a range of order of days. And for n meetings, so the time complexity will be big O of n into days. And space complexity will be big O of days. So let's look at approach 2, which is an optimization of approach 1. So in this case, we are declaring an integer array of size days plus 2. So what I will do for each meeting, so let's say the meeting start and end time are I comma j. So for each meeting, I'll increment, let's say this is an DP array. So I'll increment the ith index by 1 and I will decrement index j plus 1 by minus 1. So for example, we'll take the first meeting 5 comma 7. So I'll increment the index 5 by 1 and I will decrement index 8 by minus 1. Similarly, I will go to next meeting 1 comma 3. So I'll increment index 1 by 1 and I will decrement index 4 by 1. Similarly, I will go to the next meeting. I'll increment index 9 by 1 and I will decrement index 11 by 1. Then I will run a loop starting from the first day till the end of the DP array. So for each index, I'll try to maintain a cumulative sum. So DP of file will contain sum of index 0 to I. So this can be done in a for loop. So what we need to do for each index dpi, we need to do dp of I plus dp of I minus 1. So for the first index, it will be dp of index 1 plus dp of index 0, that will be 1. For index 2, it will be 0 plus 1, 1. For index 3, it will be 0 plus 1, 1. For index 4, okay, so for index 4, it would have been minus 1 because for the meeting 1 comma 3, it would have been decreased by 1. So for index 4, if I take the cumulative sum, it will be 1 minus 1, it will be 0. Similarly for index 5 it will be 1. Index 6 it will be 0 plus 1 1. Similarly for index 7 it will be 1. For index 8 it will be minus 1 plus 1 0. For index 9 it will be 1. For index 10 it will be 1. For index 11 it will be 0. So we can see the indexes where the value is 0. We can say those days are not part of any meetings. So we can see the day 4 and day 8. At those index, the value is 0. So we can maintain a count variable or result variable initialized to 0. After this step, at each index, we can check if dp of I double equals to 0, then increment the result. So at the end, we'll see result will be 2 because of index 4 and index 8. So time complexity will be, for the first step, it will be theta of n, because for each meeting we are doing two operations, increment and decrement, and the next step we need to accumulate the result, so that will be theta of number of days. So we can say the time complexity will be theta of n plus theta of days, or we can say big O of maximum of n comma days. Space will be theta of number of days. But in the problem we are given that number of days will be less than equal to 10 to the power 9. So this is a very big number. So if we allocate this many space, then we will be getting memory limit exceeded error. So the approach 1 and 2, it's better to know, but these two approaches will throw memory limit exceeded error if we try to solve this problem. So now we'll look at another approach which is based on sorting. Now let's look at approach 3 based on sorting. So what we need to do, we'll first sort the meetings array according to start time of each meeting. So after sorting the meetings array according to start time of each meeting, the meetings array will be 1, 3, then 5, 7, then 9, 10. Then what we need to do, we need to maintain two variables, that will be end variable, and we'll also maintain a counter called no meeting days. It will calculate the number of days which are not part of any meeting. So initially we'll assign the end to the first meeting's end time, so that will be 3. We'll assign number of meeting days equal to first meeting's start value minus day 1, that will be 1 minus 1 0. For example, let's say the first meeting after sorting is, let's say, 2 3, then day 1 is not part of any meeting. So in that case, so initial value of number of meeting days would have been 2 minus 1, that will be 1. So now we'll look through the meetings array. So we'll go to the next meeting. We can see the starting of this meeting is greater than the end of the previous meeting. So basically what we are doing, we are basically merging the meeting intervals. So in this case, what we need to do, we need to add the days which are not part of any meeting. So we can say 5 minus 3 minus 1. These many days are not part of any meeting. So we will also add this value to the no meeting days. Then we'll update the end value to the maximum of current end and the end of the current meeting. So it will be 7. For example, let's say meetings were something like 1 to 6, then 3 to 5. In this case, when we start traversing the meetings array, so the end will be 6. When we process this meeting, so the end should be maximum of the current end and the end time of the current meeting. So it should be maximum of 6 comma 5, which will be 6. Now we'll go to the next meeting. We can see this current meeting start time is greater than the end time of the previous meeting. Then we can say there are some meeting days which are not part of any meeting. So we'll count the number of days which are not part of any meeting as 9 minus the current end 7 minus 1. And we'll add that value to the variable no meeting days, and we'll update the end value to the maximum of 7 comma 10. That will be maximum of 7 comma 10, that will be 10. And at the end we'll check if end value is less than the number of days. Then in that case we will also need to add those values to the no meeting days. So let's say if end was 9 and number of days were 10, then we know that the 10th day will not be part of any meeting. So you also need to add that value to the variable no meeting days. So in that case, we need to add days minus end value to the no meeting days variable. So if let's say for example end is less than the number of days, add days minus end to no meeting days. So in this case, the result will be 0 plus 5 minus 3 minus 1, that will be 1, plus 9 minus 7 minus 1, 1, that will be 2. So let's take another example. We'll sort the meetings array according to the starting time of each meeting. So after sorting, it will be 1 comma 3, then 2 comma 4. We'll start with end equal to 3 and no meeting days variable as 1 minus 1. So 1 is the start time of the first meeting equal to 0. Then we'll go to the next meeting. We can see or the start time of current meeting is less than the end of the previous meeting. So we know that there are no days missing. So we'll just update the end variable to maximum of 3 comma 4, that is 4, and we'll stop, and we can see end is less than the number of days, that is 5. So we also need to account all the days at the end which are not part of any meeting. So we also need to add those values to the variable no meeting days. So we'll also add 5 minus end, that is 4, equal to 0 plus 1 equal to 1. So you can see for this example the result will be 1, and for this example the result will be. So complexity wise, so what we are doing, so we need to calculate time complexity. So first we are doing sorting. So this step takes order of n log n time. Then at the end we are merging the intervals. It takes theta of n. This is a higher order term. So the time complexity will be, we can ignore this smaller term. So the time complexity will be order of n log n. Now we'll go through the code. So you can see in the first step I'm sorting the array and I'm maintaining two variables, end and no meeting days. I'm assigning the first meeting's end time to end variable, and I'm also assigning first meeting's start day minus 1 to no meeting days. So as I discussed, let's say if the first meeting start day is day 2, then we can say the first day is not part of any meeting. So this step is used to calculate the initial days which are not part of any meeting. Then I will start from the first meeting and I'll check if the start of the current meeting is greater than the end of the previous meeting. I'll add the missing days to the no meeting days variable and I'll update the end day variable. At the end, I'll return the sum of no meeting days plus days minus end. So this days minus end adds the days at the end which are not part of any meeting days to the result variable, and at the end will return the sum of no meeting days plus days minus end. So as I discussed, the time complexity will be order of n log n, and space complexity will be big O of 1 or big O of n based on the internal implementation of the library sorting algorithm which we are using here. Thank you.